Okay, so it says, the most difficult problem yet. It says Wells lists four answers, but there's only one. I do indicate I'm taking a different approach than Wells would take to solve the problem. And Wells is using a substitution, and that's fine. You can do that. It's not bad. I will do that in other problems, by the way. But traditionally, what students would do with a problem like this is isolate the radical, square both sides, and then try to solve. So I went through that, and certainly if you watch this video over here, you'll see that, me going through that. But I do say in the video that of me going through this at the whiteboard that a graph would be helpful to illustrate there's only one solution to the problem. So I want to go to Grapher and explain how a graph would be helpful. So I want to go to Grapher, and Grapher is an application that allows me to graph two things here, or more than two things actually, as many things I like. What I do is I graph the right-hand side, all right? So the right-hand side I want to point out, maybe I should color that graph a little differently. Let me color it, let me color it green. So I hope you see and I'll pull this thing around for you. I hope you see that I'm graphing the right-hand side, which is 4x square root of x squared plus 5x minus 8. And I'm also going to graph the left-hand side, which is 5x squared plus 5x minus 165. And let me color that something different too. I'm going to color it, color it blue. All right? Now, certainly I'm looking at it, and certainly if we're looking at something, I realize some students are going to say, oh, it intersects over here. And let me just show you that it doesn't intersect there, all right? So what I'm going to do is I'm going to zoom into that region over here. Let me do that. And I know it's really hard to see that. But I want to point out, if you look at the green curve and the blue curve, although they appear to be intersecting, like when I zoom out, you notice they're getting closer and closer as I zoom out, but they're never touching. It's almost like you're far away from something. You say, oh, they look like they're touching, when in fact they're nowhere near each other. All right, and I'm going to say they're nowhere near each other when I zoom in. Let me go over that again. When you zoom into this region over here, the closer you get, the more you start to realize they're separated by a space. They're not touching one another. So they didn't touch there. All right, let me zoom out again. All right, and so, I got the problem over there, and this thing's going down, so there's no intersection in this area over here. But then when I move to the right side, I want to point out the green curve and the blue curve appear to be intersecting somewhere. So I'm going to zoom out of that, and I'm going to zoom back into that region. Now I have another line drawn. Let me tell you what that line is. That's the line x equals the place I said they intersected, right, which was 25. Let me make sure it's in the notes for you. I said they intersect at 25 plus 5 root 157 over 6. So I just graphed x equals, and I'm seeing it. It's right over here, all right? Now at this point, if you notice the green and blue curve will intersect over there, all right? You could zoom into that region, and the closer you get, you're going to start to see clearly they're touching each other there, all right? By the way, in appearance, however, you could also go to a computer algebra system and verify. What I mean by these numbers are really tough to do by hand computation, and verify it's true. There's only one solution to the problem, right? Now, someone says, why did Wells come up with 4? The number one reason Wells came up with 4 is he solved the quadratics. He got 4 separate solutions of the quadratic. What they weren't doing is checking, though, and I understand why they weren't checking. This document was written before there was a digital computer. They had to employ people to do the solutions to the problems, by the way. I mean, I don't think Wells was working on every problem. It takes a lot of time. It's taken a good part of my spare time to do this key. I mean, a lot of time. Now, granted, they had people employed. They were called computers that would write up solutions to the problems. Maybe they got a little bit lazy sometimes and didn't check their work. Or maybe they didn't have enough money to pay someone to check the work. All right, that's possible too. I'm not sure. But here's the deal. Wells's answer key does not contain any work. So I have no idea what they've done. None. There's no recorded history of that. That stuff was probably thrown out long ago. All I have is Wells's 4 answers listed. That's it. No work, no reason, nothing. Just the 4 answers. 3 of the answers were wrong. 1 of the answers was right, by the way. please pay attention to checking. It is so important, particularly when you're manipulating roots. You could introduce extraneous solutions to the problem quite easily. Thank you.